Hello, my fellow AP Stats students. I don't know. I'm going to keep this very simple. No fancy YouTuber stuff here. But basically, to explain how I answered this question, first I'm going to read through the question, explain what I underlined and why I underlined it, and then we can go through and look at each of the A and B questions and like how I answered it and what I got from the question. Okay, let's get started. As a part of its 25th reunion celebration, the class of 1988 students who graduated in 1988 at a state university held a reception on campus. In an informal survey, the director of alumni development asked 50, and then I went ahead and underlined 50, as you can see on my paper, because they're telling us what the sample size is, and that's probably going to be important to know. 50 of the attendees about their incomes. The director computed the mean income. Here I also underline mean income because whenever it's telling you the mean, that's going to be something that you want to pay attention to, and they're probably going to ask of the 50 employees to be $189,952. And then I obviously underlined that because that's like the actual mean. In a news release, the director announced the members of our class of 1988 enjoyed resounding success. Last year's mean income of its members was $189,952. Okay, and then question A is, what would be a statistical advantage of using the median of the reported incomes rather than the mean as the estimate of the typical income? So basically what this question is asking is, what is the benefit of using a median in this situation other than a mean? And so this is kind of brings us back to when we're learning about distributions and how distributions can be skewed left or right based on outliers. So basically, when you're trying to answer this question, what you have to think about is, in this context, the mean is going to be affected by any outliers. So what that means is if in this sample of 50 people, one or two people makes like an absurdly large income or like someone makes an absurdly low income, that's going to affect what our mean actually is in this data. And it's not going to give us a true representation of the center, like the true center of the data, because those outliers are going to pull the mean up or down. So that's something you have to be aware of when answering this question. And that when you think about that, it kind of makes you realize that using a median would be better than a mean in this situation, because we don't know if the income, the true center income was around $100,000 a year, because 49 of those 50 people could have been making like 50 grand a year, and someone else could have been making $1 million, which just would have pulled up the mean and made it inaccurate to the true average of this graduating class's income. And so my answer to this question was, using the median income of these 50 students would provide a statistical advantage over using the mean income, because the mean would be pulled up or down by any outliers in the data, whereas the median will provide a true representation of the center of the income for these 50 students. And what I need to add, or would be helpful to add, is this will happen because a median is resistant to skewedness and outliers. And it's going to give us the true middle, the true average of these incomes that we've collected. All right, now we're going to go back to the FRQ sheet to look at what question B is asking us. So here in B, they're asking, the director felt the members who attended the reception may be different from the class as a whole. A more detailed survey of the class was planned to find a better estimate of the income as well as the other facts about the alumni. The staff developed two methods based on available funds to carry out the survey. Method 1, send out an email to all 6,826 members of the class asking them to complete an online form. The staff estimates that at least 600 members will respond. And here in these questions, I'm just underlining any numbers I see because most likely we'll have to go back to those in our answer. And then method 2, select a simple random sample of members of the class and contact the selected members directly by phone. Follow up to ensure that all responses are obtained. Because method 2 will require more time than method 1, the staff estimates that only 100 members of the class could be contacted using method 2. Which of the two methods would you select for estimating the average yearly income of all 6,826 members of the class of 1988? Explain your reasoning by comparing the two methods and the effect of each method on the estimate. So basically in this question, they're asking you to choose method 1 or method 2 in which one you think would be a more accurate representation of the variability in this population, and then to also explain why. And so upon first look, a lot of people, including myself, would think that method 1 would be better because it produces a larger sample size with 600 versus only 100 in the sample size of method 2. But if you look more closely at method 1 and method 2, you'll notice that method 1 isn't completely randomized and actually is volunteer-based. So if it's volunteer-based, you have to worry about response bias. And because they're sending out a survey to the 6,000 something people in this graduating class, and not everyone's going to respond, it's very possible that the people responding are only the ones who did well for themselves and they feel comfortable responding their income, whereas that won't provide a true representation of the variability that is in this population. Whereas method 2, while it does produce a smaller sample size, is truly randomized because you're selecting a simple random sample of 100 from this entire population of 6,826. And since it's completely randomized, it can be generalized to the population, and you don't have to worry about any sort of response bias because they follow up until they get an answer. And that way, you're getting a way more random and way more representative sample of the data where you can actually see the range in income for this graduating class. Okay, moving on to the second FRQ on our worksheet. The question goes, people with acrophobia, fear of heights, sometimes enroll in therapy sessions to help them overcome this fear. Typically, 7 or 8 therapy sessions are needed before improvement is noticed. A study was conducted to determine the drug D-cycloserine used in combination with fewer therapy sessions would help people with acrophobia overcome this fear. Each of the 27 people, and I underlined the 27 people because most likely that's going to be our sample size, who participated in the study received a pill before each of the 2 therapy sessions. 17 of the 27 people were randomly placed to receive a D-cycloserine pill, and I underline this part because most likely that is going to be one of the samples that we're going to use, when we're splitting this up randomly. And then I also underline what it says, and the remaining 10 people received a placebo. So those are our 2 groups, the people who received the medicine and people who received a placebo, and both of them are receiving 2 therapy sessions. After the therapy sessions, none of the 27 people received additional pills or therapy. 3 months after the administration of the pills and the 2 therapy sessions, each of the 27 people who was evaluated to see if he or she had improved. And then we're going to move on to the first question they're having us answer, which is, was this study an experiment or an observational study? Provide an explanation to support your answer. Okay, so basically what this question is asking us to do is to look at the study done and described before us, and they want to know, is it an observational study, which means that the researchers merely found an instance that where they wanted to record what they saw, or was it an experiment where the researchers directly influenced the explanatory variable to see what the response variable would be? Well, for this question, or for this scenario, it looks like it's going to be an experiment because the researchers took 27 people who participated in the study and directly randomly assigned 17 of them to receive the medicine and 10 of them to receive a placebo. If this were a study, they simply would have found people who had acrophobia and were being treated with this medicine and study their results, and then they would have just found people who weren't taking this medicine and study their results with their acrophobia. But in this situation, the researchers are directly saying, okay, 17 of you are going to randomly get a medicine pill, and 10 of you are going to randomly get a placebo, but no one's going to know which one you're getting to, so that people don't have a placebo effect. So to answer this question, I said this was an experiment since the researchers directly influenced through random assignment that 17 of the 27 people in the study got a D-cycloserine and the other 10 got a placebo. The researchers also controlled the other variables in the experiment by making sure both of the groups had 2 therapy sessions and no more than that. And them making sure that both groups only got 2 therapy sessions and no more nor less than that, them controlling that variable is an instance in which they're controlling the confounding variables. And confounding variables are any variable that could affect the response variable that isn't the one that the researchers are directly changing. Okay, on to question B. When the data were analyzed, the D-cycloserine group showed statistically significant more improvement than the placebo group did. Based on this result, would researchers be justified in concluding that the D-cycloserine pill and 2 therapy sessions are beneficial as 8 therapy sessions without the pill? Justify your answer. Okay, some key things that I underlined or was just aware of in this question are, one of them is them mentioning that the D-cycloserine group showed statistically significant more improvement than the placebo group. So this is saying that they did a hypothesis test, found the p-value, and the p-value was less than the whatever alpha value they were using, which means that there was a statistically significant improvement that wasn't caused just by random chance, which means that obviously the D-cycloserine had some sort of positive effect on the people taking it. Okay, so now that we know we're talking about statistical significance, we know how to answer those types of questions when we're doing hypothesis tests. So basically, all you have to do is say something along the lines of, while the D-cycloserine group showed statistically significant improvement in comparison to the placebo group, this only gives us enough evidence to reject the possibility that there was no improvement. However, we cannot confidently state that the medicine is as beneficial as 8 therapy sessions. Now, I know I just said that obviously the medicine had some sort of positive improvement on the people taking it versus the placebo group, and that improvement was statistically significant. However, remember how even when we fail to reject the null, that doesn't always mean the null is true. And in this instance, the question is saying that the null would be that the D-cycloserine pill was just as beneficial as the 8 therapy sessions. However, we've only gotten enough evidence to say that the D-cycloserine pill had some positive improvement on the patients taking it, but we don't have enough evidence to say that it was the same as those patients taking 8 therapy sessions. So when you're answering your question, you have to be aware of, even though we rejected the null, we didn't fail to reject the null. Even though we rejected the null, that doesn't mean that the alternate hypothesis is necessarily going to be true. It just means that the null hypothesis is not true. Okay, now we get to move on to C, which is our final question. A newspaper article that summarized the results of the study did not explain how it was determined which people received D-cycloserine and which people received the placebo. Suppose the researchers allowed the therapist to choose which people received D-cycloserine and which people received the placebo, and no randomization was used. Explain why such a method of assignment might lead to an incorrect conclusion. So basically, this question, while longer, is pretty simple, as it's just asking us to say, why would an assignment without randomization, why would that not be a proper way to carry out this experiment? And so all you just have to know is that we're being asked to explain why randomization is important in studies and experiments, and the reason it's important is because if a study is randomized, then we can apply that to that we can generalize that to the population, whereas if it's not, then we can't generalize that to the population or imply causation. So what I ended up putting as my answer was, if the researchers were allowed to choose who got the medicine and who got the placebo, we would not be able to remove the possibility of bias. The researchers might unconsciously sympathize with certain participants and choose which treatment they get based on that. Without randomization, this experiment results cannot be generalized to the general population. And basically, what I'm trying to say in my answer is that if they don't randomize, even though they might say they're not biased, you cannot remove bias by human choice. Anytime a human is making a choice or consciously trying to assign something, we always will have some sort of bias, even if it's not a large bias or we don't recognize that bias. And when you're doing experiments, it's important that you don't have that bias, because that bias could greatly affect the effects of the results of your experiment, which is why this method of assignment they're hinting at, where there's no randomization, would not be appropriate for this type of experiment.